For question 2 in chapter 3, we'll be calculating delta G naught and delta S naught from delta H naught. So the equilibrium constant for some process, A goes to B, which is a reversible process, is 0.5 at 20 degrees C and 10 at 30 degrees C. Assuming that delta H naught is independent of temperature, calculate delta H naught for this reaction. Determine delta G naught and delta S naught at 20 degrees and 30 degrees C. Why is it important in this problem to assume that delta H naught is independent of temperature? So we have a lot of things to consider in this problem, and we have actually a lot to do. Okay, so let's get started. So first, we need to know that, let's just write everything down. So we're going to be calculating delta G naught, delta S naught from delta H naught. All right, and so for this is a process A, reversible process A goes to B. Okay, and we know that T at 20 degrees C, if T is 20 degrees C, then KEQ is equal to 0.5. Okay, and that T is 293 Kelvin. If you convert to Kelvin, adding 273. And at T equals 30 degrees C, KEQ is equal to 10. And so that T in Kelvin is 303. So at 20 degrees C, delta G naught is equal to negative RT ln of KEQ. That's an equation we were given. So delta G naught is equal to negative 8.314 joules per mole Kelvin. That's R. Okay, and our temperature is 273 plus 20, so that's 293 Kelvin, times the ln of 0.5. So that's equal to positive 1.69 kilojoules per mole if we convert that to kilojoules. Okay, so that's going to be 1.69 times 10 to the third joules per mole. Then if we convert to kilojoules, we get 1.69 kilojoules per mole. Okay, and so this is an unfavorable reaction at this temperature because delta G naught is positive. So if we also calculate that at 30 degrees C, then we have delta G naught is equal to negative RT ln of KEQ. So delta G naught is equal to negative negative goes on the outside. Doesn't really matter. Negative, let's fix this. Negative 8.314 joules per mole Kelvin times 273 plus 30, which is 303 Kelvin, times the ln of 10, okay? And that's equal to negative 5.80 times 10 to the third joules per mole, which is equal to negative 5.80 kilojoules per mole. So that it's favorable at this temperature. Okay, so we have delta G naught at two different temperatures. Okay, and also we know that delta G naught is equal to delta H naught minus T delta S naught, and that's an equation that we were given. So we were told that if delta H naught is not temperature dependent, okay, then let's look at our problem again. Okay, so we assume that delta H naught is independent of temperature. Okay, so if delta H naught is independent of temperature, then delta G is linearly related to delta T. Okay, so we can rearrange this equation to say delta G naught is equal to negative T delta S naught, okay, plus delta H naught. And what does that look like? That looks like Y is equal to M X plus B, okay? So if delta H naught is not temperature dependent, then that means that delta H naught is constant. And remember, in our equation for a line, B is a constant. So it needs to be a constant, so that answers that question. Why do we need it to be independent of temperature? Because delta H needs to be a constant so that we can use our this linear relationship, okay? So we can use the linear relationship that delta G is linearly related to temperature, okay? And so that means that our, I had these backwards. I meant to say that delta S is our X, is our M, and T is our X, right? Because if delta G is related to T, then delta S is the slope. So let's rewrite that. So we can say delta G naught is equal to negative delta S naught times T plus delta H naught. So delta H will be our intercept, T is our X, delta S naught is our slope, and delta G naught is our Y. Okay? So that would be the relationship between these. So what can we do? We can say that our slope is equal to y minus y1 over x minus x1. Okay, so that means that we can say our delta G over the temperature, okay? Our change in delta G naught over the change in temperature is going to give us our slope. So we actually have 2 points. Let's go back. So we have one point where we have 20 degrees C. Our delta G naught is 1.69. And at 30 degrees C, our delta G naught is negative 5.80. So we can use that for our Y's and our X's. Okay, so we can say that our slope, which is our negative delta S naught, okay, because it's negative there, is equal to negative 5.8 minus 1.69 divided by 303 minus 293. So those are our 2 points. That is our temperature. Okay, our temperature is our X, and our delta G naught is our Y. Okay, and so our temperature at the delta G of 5.8 is of negative 5.8 is 303. Okay, and our temperature at 1.69 is 293. Okay, so we can calculate that delta S as the slope if we say that delta H is constant or independent of temperature. All right, and so that gives us negative 0.6 0.75 kilojoules per mole. Is that right? Yeah. For our negative delta S0. All right. So if we take away the negative sign, delta S naught is equal to 0.75 kilojoules per mole. Okay, so moving on. So what was the rest of this question? It said calculate, assuming that delta H, calculate delta H, determine delta G and delta S at 20 degrees and 30 degrees. Okay, and then we need to calculate we got delta G at 20, we got delta G at 30, we got delta S. Okay, so we need to calculate delta H. All right, so let's do that. So let's go back up here. We got delta G at 20, we got delta G at 30, we got delta S, and so we need to calculate our delta H. Okay, so our equation for that is delta H naught is equal to, or approximately equal to, delta G naught plus T delta S naught if we rearrange our equation. Okay, and so that means that at 20 degrees C, delta H naught is equal to 1.69 kilojoules per mole plus 293 times 0.75 is equal to 221.5 kilojoules per mole. And at 30 degrees C, delta H naught is equal to negative 5.8 plus 303 times 0.75, which is equal to 221.5 kilojoules per mole. So we see that delta H is in fact independent of temperature. Okay, so we've calculated delta H naught to be 221.5. Delta S is equal to 0.75, and at 20 degrees C, delta G naught is equal to 1.69, and at 30 degrees C, delta G naught is equal to negative 5.80. All right, so that is everything we were asked to calculate.